So over here I have a few questions. So when there's 17 grams of fat, how many calories is there typically in a sandwich? So how would we go about figuring this out? Basically, we know we're looking at 17 grams of fat. So I'm gonna look at my grams of fat side and figure out where it's 17. In this case, it's about right here. I'm gonna go ahead and draw a line up to where my scatter plot is. And it happens to be at that dot right there. Now at that dot, how many calories are in that sandwich? Well, let's go ahead and drag it across. 400. So in a sandwich that is about 17 calories, there appears to be 17 grams of fat. There appears to be about 400 calories. Okay, well that's nice enough, but what if we wanted to go the other way around? What if we wanted to figure out what about 600 calories? How many grams of fat is that? So since I'm looking at calories first, I know I have 600. So I'm going to find 600 on my graph. There it is. And make a line across my scatter plot. So I happen to hit this dot right here. But how many grams of fat does that dot have? Well, let's go to our other axis and figure out. 30. So according to our scatter plot, and this marker is running out, according to our scatter plot, a 600 calorie sandwich is equal to 30 grams of fat. We are just using this to kind of compare relationships. So here's a question. What tends to happen to the number of calories as grams of fat increases? So I'm trying to figure out what's happening with the number of calories as grams of fat increases. So let's see, I'm gonna follow my graph along this way, and as my grams of fat increases, my dots kind of appear to go higher and higher and higher, meaning that at the same time that my grams of fat increases, my number of calories increases as well. So as grams of fat increase in this case, number of calories increase. This is what we call a positive relationship. A positive relationship pretty much says as X increases, Y also increases. And as a matter of fact, you can say it's the other way too. You can say, I can find my green marker, as X decreases, Y also decreases. So let's go ahead and look at that graph one more time. So in this case, we know our X is on this axis right here. As these dots increase from left to right, we're also increasing upwards. Same thing if we go the other way. As my dots decrease in fat, they're also decreasing in calories. So a positive relationship doesn't necessarily mean that the outcome is positive. It just means that they're going in the same direction at the same time. So if it's increasing in the X direction, it's also increasing in the Y direction. If it's decreasing in the X direction, it's also decreasing in the Y direction. This one also happens to be kind of in a linear fashion. So we would actually call this graph a positive linear relationship. So if we have positive relationships, do you think that negative relationships also exist? And they do. So a negative relationship is pretty much the opposite. X and Y don't move together. So as X increases, in this case Y is decreasing. Or you can say it the other way, as X decreases, Y increases. A negative relationship doesn't mean anything bad, it just means that they're doing different things at different times. And in this case, these both form a linear pattern, so we would call these negative linear relationships. We also have relationships that don't fit either category. So this can be called nonlinear relationship as well as no relationship. In a nonlinear relationship, we can see that there's some sort of pattern going on. In this case, it kind of makes a swooping pattern upwards. We know it's not a line because it's not straight, and lines have to be straight. They also have to have a constant slope. But In this case, there is some pattern going on, so we would just call it a nonlinear relationship. Now, when it comes to no relationship, there is no pattern. There's no shape or line or curve or anything that I can draw that would make this into anything that we've ever heard of or ever seen before. So we just call it this is a nonlinear relationship, and we call this a no relationship. So let's look at some examples really quick. So this graph right here compares TV size in inches to their price. What kind of relationship do you think this is? I would call this a positive linear relationship. The reason I would say positive is because as TV size in inches increases, price also appears to increase. They go in this direction. Plus, it pretty much looks like a straight line, except for this dot right here, which I would consider an outlier. Looks like a pretty straight line, which I will actually show here. And we will actually talk about how to make lines like this in the next video. All right, what about this other graph? This is a person's age in years versus the number of pets that they've owned. So in this case, there really isn't a pattern. I can't draw any sort of line through this that would make sense, or even like a curve wouldn't make sense. So we would call this no relationship. There's no relation between the people that have had X number of pets versus their age, and that's okay.